Luke, can you get me one?
Oh, you'd like to borrow this?
Let you have it. I Xeroxed it, and you can have it for all the trig we do. And you'll need it for a bunch of the trig we do.
Is it recording?
Yes, we're now recording. Today is the 16th, February 16th, 2010, and we are looking at sum and difference formulas.
That's my favorite.
Who's going on one try? Take the other test.
We're combined, talk to me, we'll have to figure it out.
Me too.
Yeah, I know, we got a lot of people that make stuff up, so just come and meet me at lunch and we'll set appointments one-on-one.
Isn't it formulae?
I don't think so. Maybe in the original Latin, but I'm not entirely sure the formula is Latin. I don't know if it's Latin or Greek. If it's Greek or, hypotenuse is actually Egyptian. So that's why it's not, multiple ones aren't hypotenae. Okay, sum and different formulas. These are formulas that used to be crazy practical useful in the pre-calculator days. They really sped things up a lot for simple calculations. Now they're still used to transform functions, something we may or may not get to, but I want you to have seen them. There are some tricks to memorizing them, but you'll have a cheat sheet, but if you know the tricks, you're less likely to screw it up. Just so you know, Honors Precalculus is on this unit with no cheat sheet, so they're memorizing this stuff. If you have the sine of two angles being added together, and your book uses u plus v, so I'll use them as well, that is the sine of u, the first angle, times the cosine of v, the second angle, plus the cosine of u times the sine of v. Give you a quick example of why this might have been practical in the past. Okay? What if I did not have a calculator and I'm figuring something out and I need to know the sine of 105 degrees with no calculator and perhaps only with the chart in front of you? Saul, what are you thinking?
You do sine, cosine, 105 degrees, and you do cosine, sine 105 degrees?
Well, now the thing is, you don't know the sine of 105 degrees without a calculator. That's not. What are the signs that I asked you to know? Like that off the top of your head and fill out the chart.
Oh, 60.
60, 90, 30, 45.
You can add them and subtract them. And...
Yeah, if there's certain numbers, this was really easy. And if you're really clever, you could find almost anyone. 105 could be a combination, guys, of what two angles that you should know? 60 and 45. So if I rewrite this as sine of 60 plus 45, then I can rewrite it, 60 degrees plus 45 degrees is 105 degrees, right? Then I know that this becomes the sine of 60 degrees times the cosine of 45 degrees plus the cosine of 60 degrees times the sine of 45 degrees. This is now a totally fair non-calculator question, especially since I'll let you have that cheat sheet. Okay? Because from here, you should know off the top of your head from the chart, or be able to refigure them. The sine of 60 degrees is square root of 3 over 2. The cosine of 45 degrees is square root of 2 over 2. The cosine of 60 is 1/2. And the sine of 45, is root 2 over 2. So this becomes, when you multiply fractions, you multiply the numerator and the denominator. When you multiply radicals, you multiply what's under them. This becomes the square root of 6 over 4 plus the square root of 2 over 4. Final answer is the square root of 6 plus the square root of 2 over 4.
Can you combine them? So
No.
The same denominator.
Oh, I can combine them into this with the same denominator,
right.
but I can't add the two
So can you put just sine,
radicals.
sine 105 in your calculator?
Yes, but I won't let you.
Why?
I'm going to give you a non-calculator test with cheat sheet. So you'll be doing it this way, and your answer will look like
We
this.
don't have a cheat sheet.
Pardon?
Yeah.
Well, I'll make another copy, but it's this page. If you want to Xerox that.
Can you make one?
Can you
Yes.
switch it around?
Can you switch around? That's a great question. On addition, it doesn't matter. Okay, one way to remember this is the sine formula is, as long as you mix and match the sine and cosines, you can add this in either order. As long as you get the sine of 60, the cosine of 45, and the cosine of 60 and the sine of 45, you can do it in any order you want.
Actually-
But that's going to change in a minute.
Well,
What you- Yes.
Actually, if one of the angles is 45, then you don't have to get it right. You can be wrong and still get the right answer because
The sine and cosine of 45 are the same, yes.
Yeah, so as long as you know that's root 2 over 2, even if you switch the sine 60 and cosine 60, you still get the right answer.
Yes, in this case you can mix it up. So that's the thing, Jesse. Sometimes you want to be careful because sometimes, as Sam has pointed out, you can mix it up and get the right answer, but other times you can't.
You wouldn't take off on that, would you?
Getting the wrong answer?
No.
Yes, I actually would.
Getting the right answer for the like.
I'll actually do. If I see in your work that you got the right answer the wrong way.
Yeah.
I did.
I would take opposite heat.
I did. Okay, I'm going to erase this one. Again, you have it.
Yeah.
You got it right though.
Now, for the sine, yeah, but I like to teach processes. Remember that Algebra 2 test, Luke, where I was like, here's the answer, do it 5 different ways?
Yeah.
Okay, if you have the sine of the difference of two angles, okay, the sine of the difference of two angles, then it's the same thing. You mix and match. It's the sine of the first angle, cosine of the second, minus the cosine of the first angle, sine of the first. For this one, you have to get the order right. But again, for you guys, I'm going to let you have a cheat sheet. You have to get the order right for this one. An example for where you would use this, and a problem I would give on the next test, would be, what is the sine of 15 degrees?
Could you do the same?
40
Could you,
minus
45.
45.
I believe you had the right idea, but... Okay, this would be the sine
60 minus 45.
of... You can do 60 minus 45, too. You can do a bunch of things. You can do 45 minus 30, and then you got to plug them in carefully here. So that's the sine...
Wait, that's what I said.
You said 40 minus 30. You left off the 5. That's all.
Oh.
Yeah, I know. It's a mental typo. So the sine of 45 is root 2 over 2 times the cosine of 30, which is root 3 over 2, minus the cosine of 45 square root of 2 over 2, minus the sine of times the sine of 30, 1/2. And in this case, what you're going to get is the square root of 6 minus the square root of 2 over 4. Square root of 6, square root of 2, and over 4 show up a lot in these, because all of our examples are...
Wait. That's not over 4.
2 times 2 is 4?
Yeah. Oh, my bad.
We can review these basic concepts if you'd like, Sam. I know they're
I
complicated.
would.
So, Jesse, here's the next formula, and here the order matters much more because you have subtraction, and you've got subtraction between them. You can add in either order, you can't subtract in either order. Okay, so you got to make sure you use the formula right. Yes?
What does U and V stand for?
Like theta, so theta 1 and theta 2. One angle and another
X and
angle.
Y.
It's like X and Y, but for angles.
What X and Y would...
It'd be fine. Yeah. I think I learned this in high school with theta sub 1 and theta sub 2.
Yeah, I think
That was like octave.
Pardon?
So that looks like octave.
It does. I don't like that one. So I thought, your book uses U and V. So I thought I'd use that one. Those are your first two formulas. We got 4 more to do examples of. Are you ready?
Wait for me to get back.
No, but thanks for asking. Okay, next one is cosine. Okay, for the sines, it was the sine of u plus v is sine u cosine v plus sine v cosine u. Okay, there were sines and cosines mixed up. For the cosine formulas, are more like, I just want to say discriminating. The sines and cosines stay together; they don't mingle.
They're segregated.
Yeah, it's a little bit sad. Cosine u, cosine v, minus sine u.